Assalamu alaikum. Welcome to this Power Word Simulator tutorial. In this tutorial, I am going to teach you how to perform three-phase fault analysis in Power Word Simulator software. I have taken an example from the book Power System Analysis by Hadi Sadat, Chapter 9, Example 9.1 and 9.2. According to this example, a three-phase fault with a fault impedance of 0.16 per unit occurs at bus 3 in the network given below. Using the bus impedance matrix method, compute number 1 the fault current, number 2 the bus voltages, and number 3 the line currents during the fault. The mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Now I am going to model the three-phase fault analysis in Power Word Simulator software. Let's start. Just click on this icon to open the Power Word Simulator software. Click on this icon to open a new model. For better visibility, go to the options and click on Draw Grid. Change the grid horizontal to 4 and click on Draw Grid Lines in order to make them appear here. Just look at the figure, which consists of 3 buses. Therefore, first we need to put 3 buses in the model. For this purpose, go to Draw and click on Network and click on Bus and insert it anywhere in the screen. A window will appear. Write here Bus 1 and increase the display size to 15. Select this bus as Slack Bus and click OK. Similarly, repeat the same procedure to put 2 other buses. Now we need to connect transmission lines with the buses. Look at the figure. From bus 1 to bus 2, the reactance of the transmission line is 0.8. Therefore, take transmission line from here and connect both buses and put the value 0.8 here. Increase the display size to 3 and click OK. Double click on this meter and write 1000 here in the MVA rating and change the color if you want. I choose blue in this case and click OK. Now we need to connect the transmission line between bus 1 and bus 3. Again take the transmission line and connect between these 2 buses and put the value 0.4 here. Increase the display size to 3 and click OK. Now we need to connect the transmission line between bus 2 and bus 3. Again take the transmission line and connect between these 2 buses and put the value 0.4 here. Increase the display size to 3 and click OK. Now we need to connect the generator and transformer at bus 1. Therefore, take the generator and connect across bus 1. Double click on it and window will open. Put here any arbitrary value or put 0. In the fault parameter, put positive sequence reactance to 0.1. It is because in balanced system, actual impedance is always equal to positive sequence impedance. You may notice that this generator block gives the option to connect the transformer in combination with generator. Therefore, put here 0.1 as the transformer reactance as given in the example. Increase the display size to 10 and thickness to 5 and click OK. Similarly, we need to connect the generator and transformer at bus 2 as shown in the figure. Therefore, take the generator and connect across bus 2. Put here any arbitrary value or put 0. In the fault parameters, put positive sequence reactance to 0.2. Similarly, put 0.2 here as the transformer reactance as given in the example. Increase the display size to 10 and thickness to 5 and click OK. Now you can run the simulation. Just click here on Run mode. Go to Tools and click on Play button. Now click on Fault Analysis. A new window will open. This window provides all details about the system. As we know that the example asks to apply 3-phase fault on bus 3 having fault impedance 0.16 per unit. Therefore, click here on bus 3. Select 3-phase balanced fault. Put the fault impedance to 0.16. Now you can click on Calculate button to measure all the values. It can be observed that when fault is applied at bus 3, the fault current magnitude in per unit is 2. The bus voltage during the faults are shown here. You can compare the answer with the answer obtained in the example. It may be noted here that when fault is applied at bus 3, then its voltage should be 0. However, here it shows the voltage of 0.32 per unit. Can you guess the reason? The answer to this query is that voltage is not 0 because there is ground impedance available which is 0.16 per unit. Therefore, some voltage is dropped across this impedance. If the ground impedance is 0, then the voltage across bus 3 will be 0. To prove it, just make the fault impedance 0 and calculate again. You can see when fault impedance is 0, then voltage of the faulted bus will also be 0. The fault current in that case will be higher as shown here. You can also compare the results of the line currents with the measured currents in the example. It can be observed that all the answers are correct. To compare the admittance matrix, just click here. It may be noticed that both results are correct. Up to now, we have calculated the fault current, bus voltages and line currents when fault is applied at bus number 3. Now suppose if fault occurs at bus 2, then what will be these values? To do this, just click on bus 2 and click on Calculate. You can compare the answers of the fault current, bus voltages and line currents with the answers obtained in the example. You can see all results are accurate. Now suppose if fault occurs at bus number 1, then what will be these values? To do this, just click on bus 1 and click on Calculate. You can compare the answers of the fault current, bus voltages and line current with the answers obtained in the example. It can be observed that all results are correct. Friends, in this tutorial, I have discussed how to perform 3-phase fault analysis in PowerWorld Simulator. I have discussed how to simulate three-phase fault and calculate the fault current, bus voltages, line currents in the Power Word Simulator. By doing the same way, you can perform three-phase fault analysis of any power system problem. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.